Alright, so here we have a matrix A, an augmented matrix A, that's been row reduced into reduced echelon form. And the reason why we use row reduction to get a matrix down to reduced echelon form is because it gives us a solution set, an explicit description of a solution set for this linear system. Alright, and to jog your memory a little bit, a solution set basically is just a set of numbers that satisfies this system. It satisfies all the equations in the system. So that means the set of number that satisfies this, this, and this equation. Now, this augmented matrix, since it's simplified, we can go ahead and write this back into a system of equations that is simplified, and I'll do that below right here. So to write this out in a system again, as opposed to a matrix, we'll just say we have in our first row, starting at our first row, we have 1x1, we have 0x2, and we have negative 5x3 equals 1. Again, we're dealing with an augmented matrix because this line is here. That's what that tells you. So the right side of the line is the right side of the equal sign, and the left side of the line is the left side of the equal sign in a linear equation. So moving on to the second row, we have 0x1, we have 1x2, and we have 1x3 is equal to 4. And then our third row is just 0 equals 0. And I'll go ahead and write that kind of just as a placeholder to remind us what's going on here. Now in this video I want to touch on the two variables that show up in linear algebra and the two ways to classify variables in linear algebra. Now the first type of variable that we'll be working with is called a basic variable. And a basic variable is a variable that shows up shows up in one equation in our system. So in this system, x1 and x2 are basic variables, and we can see, like I was just saying, they show up in one equation, right? So x1 only shows up in this first equation. x2 only shows up in this second equation. So I'll go ahead and write these in green so we can kind of visualize this and they stand out. Our second type of variable is called a free variable. And kind of conversely to a basic variable, free variables show up in all the equations in our system. And so x3 is a free variable in this system. So I'll go ahead and write the x3's really quickly in this light green just so we can visualize it. Moving forward, I'm not going to distinguish between basic and free variables with different colors. I'll just write them all as one color, but I want to do so in this video so we can kind of see it a little better. Now, the relationship between our basic variables and our free variables is that our basic variables can be written in terms of our free variables. And to show you this, let me go ahead and simplify these equations right here in terms of x1 and x2. So for the first equation, we'd have x1, all right, and to get x1 by itself, what would I do? I would add 5x3 to the right. All right, so if I add 5x3 to the right, it's going to cancel that out, and I'm going to get plus 5x3 over here. So I'll go ahead and write that down here. 1 plus 5x3. All right. And now solving the second equation for x2, I'm going to get x2 is equal to, well, how would I get the x3 over? I would simply just subtract an x3. Okay? And that would cancel out over there. And so what I'm going to have over here is x2 is equal to 4 minus x3. All right? And again, I'll go ahead and this time I'm actually going to write out here, since we're talking, each one of these equations kind of represents what each variable means. I'm going to go ahead and just write x3 is free, right? So the first equation describes what x1 is, the second equation describes what x2 is, and the third equation describes what x3 is. In this case, x3 is free. Whenever you see a variable or variables described with respect to some of the other variables in the system, you should start to get in the habit of thinking that, okay, these are our basic variables. All right? So now, what does this mean in practice? What does this really mean for us when we think about the solution set of our system? Well, what this means is that I can choose any value for x3. Okay, I can choose any possible value for x3. Right? And I will get a solution that is in the solution set. I will get a set of numbers, x1, x2, and x3, that is in my solution set for my linear system. Right? That is a very powerful statement that might not yet really click, and the gravity of this statement does not yet, it can't sit upon you well, and I understand that. Once we get a little further, you'll start to understand exactly what I mean by that. So I'm going to write this out very succinctly, and I like the way the book puts it, so I'll put it in its terms. Okay. So the way the book puts it is this. Each different choice of x3 determines a different, this is an important part here, a different solution to the system, and each solution to our system is determined by the choice of x3. Now x3, think of free variable, right? That's all that means within the context of this problem. So generally speaking, each different choice of a free variable or our free variables determines a different solution to the system, and each solution to our system is determined by the choice or choices of our free variables.